Weaveworks. I'm a Flux CD maintainer, and today I want to give you an introduction to GitOps, Flux, and the Helm operator, which is a sub-project of the Flux CD adventure that we now have brought from Weaveworks, and now it's into CNCF sandbox, and we planning to give it even further away. So what's GitOps in my opinion? So in my opinion, you are probably using all these tools, right? All these commands to change things in your cluster, to do deployments, to do rollbacks, and so on. That means you have to share your cluster credentials to everybody that must have access to the Git repo. It also means that your CI pipelines will probably shell out to these CLIs, right? This is how most people do deployments on Kubernetes. With the GitOps model, we just ignore all these tools, and we only use git push to interact with our clusters. What that means is that someone else is running all these commands for us. What we do is just we describe our desired state. We say we have a Git repo, and we say this is how I want my cluster to look like. And it's up to the tool, some automation that runs inside your cluster to make sure that what you have described in your Git repo, it's applied, is reconciled on your cluster. So what GitOps brings to the table? Some obvious advantages are that from a DevOps perspective, both engineers, both developers and operations people can work together on how the infrastructure looks and how the applications are deployed on it. So if you have a Git repository that's shared between your teams, then you can work with pull requests, reviews. You can sign your commit so you know who did what. And you can also get this audit log for free. Like many companies out there must be SOC 2 compliant or other compliances. And Git gives you that without any kind of effort. If you switch from a CI model to a GitOps model, then every single change, it's in a Git log. And if it's signed with GPG, let's say, then you can ensure that whatever happens is there and you can trace it very easily. This is one of the advantages. Another advantage is recovery time. So let's say your cluster something happens really bad in your infrastructure that you don't control. You are on some cloud, something really happens with, let's say, your etcd cluster that everything is in there, all your configuration, and you want to start a new cluster, right, with the same stuff that was running on the previous one. If you use CI pipelines, and this is how you drive deployments, what that means is you have to go into your CI system and trigger all the jobs that are making up your cluster. You have to redeploy all your applications and so on. Right, so this is error prone because you don't really know what's running right now on your cluster. You know that, okay, there are some, you have to look on your CI system, get all those logs out of there, see what was last applied, and rerun every single job. This can take a lot of time if you have many apps. Now, you also have cluster objects. Maybe you have users and so on, and maybe those objects are not deployed by CI every time you do an app change. So with GitOps, you just say, okay, I have a new cluster. I install the GitOps operator there, and you point that operator to the Git repository that the previous cluster was bootstrapped from. And on the first run, everything should be the same as the previous one, because the desired state of the previous one is now applied on the new cluster. So in Weaveworks, we had a major incident some years ago, and this is how we managed to recover the whole thing in 15 minutes. And this is when we realized that, okay, maybe GitOps is not something that we should keep only for ourselves, and we should make this public and try to advocate for this kind of driving operations over Kubernetes. And how do you implement GitOps? There are some things here. Of course, you need a Git repository, right? So you need a Git provider. Now, choosing a Git provider means that you have to trust that provider for uptime, right? If your cluster goes down and the Git provider goes down, well, surprise, there is nothing. How can you restore something when your source of truth is gone? So be careful when you choose this one because it's a single point of failure, right, for the GitOps story. Of course, you have to have a container registry, and what I specified here, you should push only immutable images. And I will get back to that, but the idea is don't use latest. I mean, latest is not something that you can describe as the state of your app. It's latest of what, right? So don't do it. And the same thing can be applied to Helm charts. You can use a Helm repository if you don't want to keep your charts only in Git. I will show you both options. Of course, Helm is way better than a container registry because Helm enforces semantic versions for your Helm charts. So use semantic versions and don't push the same version twice. Like, this is something you should not do because you are going back to the latest problem. Okay, so when you have all this infrastructure set up, a Git provider, a container registry, maybe a Helm repository service, what you need next is you need to build a continuous deployment process that has some properties. It can watch for changes in Git, so it doesn't only rely on the Git provider calling that operator, right? So it can do this kind of watching on its own. So let's say if a Git hook is not succeeded, that doesn't mean you shouldn't change the cluster state, because if it's changed in Git, the operator should react to it. So that's why here we rely on watches and not only Git webhooks. It also can watch your container registry and detect if there are new images and take decisions based on that. For example, Flux can upgrade your containers based on some expressions, some rules that you can define for upgrading in-cluster workloads. And another thing, you should be able to detect drifts. Like, drifts is something that happens, right? Even if, let's say, your SRE team says, okay, we'll only use the Git repo to drive changes, maybe someone has access, someone definitely has access to that cluster and can do some modifications inside the cluster without going through the Git process, right? So your CI/CD system should detect that the desired state is no longer there because someone changed something inside the cluster. And also the continuous deployment system should try to correct the drift. And of course should alert on misconfigurations and drift. Misconfigurations for me here is, let's say, mild formatted YAML. Maybe if you don't have something like on each pull request on your Git repo, maybe you don't have something like kubeval or other tools that are validating your YAML, then the continuous deployment system should say, I cannot accept this malformed YAML, and it shouldn't apply anything else. So for GitOps to work, everything must be all or nothing. If you are doing a commit in your Git repo and you are changing like a dozen YAML files, and a single YAML file is malformatted, then nothing else should be applied. We shouldn't apply half of a commit, or we should apply 100% of the commit or nothing. And this is how Flux does this the right way. Okay, so how we implement this continuous deployment process. Weaveworks has started the Flux project some years ago, and this is how we implemented GitOps for ourselves, and afterwards make it open source, and now a lot of companies and freelancers and other people are using it for business needs, or just at home maintaining a cluster to play with. The whole idea is very simple. You put all these YAML files in a Git repo. Flux watches the Git repo and how it does that. For example, on GitHub or GitLab, when Flux starts up, it generates a deploy key. It's an SSH key. You give the public key to GitHub or GitLab, and afterwards Flux is able to connect to the cluster, to the Git repo, clone the Git repo, and apply the changes to the cluster. So this is how it works. Is not magical at all. What Flux does, it monitors whatever runs in your cluster, and it uses annotations to keep track of what objects are in Git and what objects got applied on the cluster. So this makes Flux ideal for also doing garbage collection. What that means is you add a deployment to your cluster, that deployment gets materialized in the, you add the deployment to your Git repo, that one gets deployed on a cluster, then with another commit, you remove that deployment from Git. And Flux will detect that, okay, on the previous commit, I had this object, now it's gone. So it will do a kubectl delete on that object. So you don't have to clean up things in the cluster and in Git. And this is like, this was a future request for about 1.5 years, and we managed to pull it off this year. So we are very happy about garbage collection in Flux. This is why I mentioned it here. Let's go on to the Helm operator at the Helm Summit, right? So what the Helm operator does. Helm operator exposes a custom resource of type Helm Release. You can keep these Helm Release definitions inside your Git repo. Flux will synchronize them. So those Helm Release files will get applied. The objects will be created. Helm operator detects that and transforms the Helm Release object into an actual Helm release. It's like simple. And it also does install, upgrade, and delete using a Flux garbage collection. You can also run Helm operator on its own. We made big efforts to, so Helm operator was developed inside the Flux repository and was part of Flux itself, the source code. Now we've pulled Helm operator into its own dedicated Git repository. It has its own dedicated Helm chart, so you can, if you don't use Flux, you just want to play with Helm operator, you can deploy it like any other operators, and when you create Helm releases, it will just work. But what I'm showcasing here is the full GitOps pipeline that I'll try to demo if I have time. Some features that Helm operator has. So it makes all the Helm operations, makes them declarative. It can pull charts from Helm repositories, like the stable Helm chart. It also can pull charts from private Helm repositories if you have basic auth or other things. And it can also pull charts from Git repositories. So if you don't want to run a Helm repository server and maintain that, you can just keep your charts in Git and point Helm operator to those Git repositories. What I mean here, what are those repositories? Usually those are app repositories where you have your source code and you also have your chart source code. You can tell Helm operator, there is my chart definition and here is the Helm release, and with the two files, with the two specifications, it will create the install. Also for the values, how you can provide values to the to your release, there are a couple of options here. You can point to secrets in your cluster, config maps, or even external URLs like an S3 bucket or something like that. Maybe you want to keep there your value files, and the Helm operator will pull them off. If you use Helm operator together with Flux, you can do automatic upgrades of Helm charts based on image tag policies. When, let's say, this is more of a Helm 2 feature, so Helm operator works with Helm 2 and Helm 3 since today. For Helm 2, there was a problem. If you first install a chart and that install fails, you cannot install it again, because Tiller will just reserve that name as a failed chart. What Helm operator does, when it sees the first time a Helm release, it will try to install it. If that fails, it does a delete and purge. So at the next iteration, at the next time it does a reconciliation, it will not error out. And if you fix your chart in the meantime, it will just get installed. So this is something that we did to make this easier with Helm 2 and Tiller. And it also does automatic rollback on chart upgrade failure. So let's say you describe something in your Git repo, you want to upgrade something in your chart, that fails. And maybe you don't want to leave it in a failed state, but you want to know that that one failed. So Helm operator will log, will emit some events that, okay, the rollback failed, the upgrade failed, and it does a rollback for you. So your state is always the last good version of your chart install. This is how a Helm release looks like. Nothing complicated. We have this chart section here where we say, okay, my chart comes from the stable repository, and this is the URL for the repository. That's the name of the chart, and that's the version of the chart I want to install. Here, if you apply this thing on your cluster, it will install seal secrets in the default namespace, because we didn't specify any namespace here, on that version with the values.yaml from the chart, right? So this is the equivalent of Helm install seal secrets. Why I have seal secrets here as an example? Because seal secrets is a controller made by Bitnami, which is now VMware, and seal secrets allows you to store secrets in your Git repository. Those are encrypted with a public key, so anyone from your team can encrypt those secrets, put them in a Git repository, and no one can decrypt them except for the seal secrets controller, which runs in your cluster. And this is how you can build GitOps pipelines without sharing your API keys, database password, and so on. You'll not just put them in clear in the Git repo. You'll put them encrypted, and they only get decrypted on the cluster side. So here we've seen how you can get tell Helm operator to install a chart from a Helm repository, and here is how you can tell it to install a chart from a Git repository. So it's a GitHub URL. It's not a Helm repository. It's actually the Git repo, and you can use the ref key to point to a release in GitHub or to a branch. So instead of ref 2.1, you can do ref master branch. And whenever you put a change in master, then Helm operator will detect it and will upgrade your chart. So while you are doing development for your dev cluster, it's very easy to just tell Helm operator, please synchronize every time with this branch. But when you are doing production releases, then you should point to a Git release assembler that doesn't change, and it's there forever, right? Yes. Yes, it's branch or tag. And the values part down below is so you can override the default values from values YAML in here inline in the Helm release. So this is how, instead of modifying charts all the time to fine-tune them for, I don't know, different clusters, different namespaces, different environments, you can specify your values inside the custom resource definition Helm release. So instead of copy-pasting charts and stuff like that, you'll just create more Helm releases based on namespace, environment, and so on. And so you can specify values inline, but you can also specify values from config maps, secrets, and also files that are inside your charts. Like, it's very common if you look at the stable chart repo, there are values YAML and production values, for example, right? So if you decide to not put all your settings inside the Helm release and you want to keep your settings like you used to do, for example, in your actual chart, you can reference here a path inside your chart directory where are the values that you want to apply. And you can mix them all together. You can put some values inline here. Your API keys should come from a secret, And maybe you have something like generic values for clusters in a region. Yes?
So that was here on the same order of priority as they are on the Helm command line?
Yes. Yes. So we use we don't use the Helm command line in Helm operator. Helm operator uses the Helm Go packages, but we try really hard to be compliant with everything Helm does. And if we do it differently, we'll get like an issue instant. Someone will notice. So this actually works pretty well, and we have it for some time. I think more than half a year. Like Helm operator started like 1 year ago, or maybe more than 1 year. Hide? No? About a year. So we launched Helm operator Alpha 1 at the first Helm Summit. And hopefully today we can launch 1.0.0, the first release candidate with Helm v3 support. Okay, so this is how you can provide values from all kinds of sources. And from here is missing the example because I didn't have enough space. It's missing the example, and you can reference a values file from something like an S3 bucket. And why would you do that? Let's say you have a bucket for each region, and you have some values for all your charts that are that must change based on region. So instead of putting those in a secret or something like that, you can just use some external URL that points to your bucket. We didn't thought about this use case. It was some Helm operator user that really insisted that his use case is good, and we should deal with the S3's bucket. So that's it. One feature that works together with Flux. So to do this, you have to have Flux on your cluster, not only the Helm operator. So Flux has, using annotations, you have a way to define how you want to upgrade your values spec. So here in my values, I have an image, a repository, and a tag. And I'm telling Flux, please upgrade my Helm release if a new 3.0 version is published. So what I'm doing here, what I'm saying, I'm not going to change my chart for patch releases of my application, right? These are, let's say, small bug fixes that don't require infrastructure change in any way. So instead of going into Git every time when I do a 3.0.1 release, or 0.2 or 0.3 or whatever, I'm trusting myself that I will respect Semver and I will not do breaking changes in patch releases, and I can tell Flux, automate this stuff for me. So every time I'm pushing to the Docker registry, in my case, a new version, Flux will apply the Semver filter, will detect, okay, 3.0.1, it's there on the Docker Hub. It will modify the Helm release file, it will commit the Helm release file to my Git repository, and afterwards it will apply it. So even if I'm doing the modifications manually with git commit and git push, Flux does the same thing. So everything that Flux changes in your cluster is not directly in your cluster. It changes it first in Git, and afterwards it applies it. So it doesn't break the GitOps pattern in any way. And also Flux can deal with GPG signing and stuff like that. So if you can issue an encryption key for Flux if you are using signing for Git repos. And this is how it looks like. So what Flux does, it scans your cluster for all containers that are running in your cluster. Then it uses the container pull secrets from the Kubernetes API. It gets that secret and connects to the Docker registries. It works with the Docker Hub, with Quay, with all sorts of registries out there. So because it uses the pull secret from Kubernetes, so it connects there, and it doesn't pull the image itself. It only pulls the metadata of the image, like how many tags are out there, and from those tags, how many are Semver. Okay, from all those Semver tags, how many apply to my filter? This one, and only then it will do a git push. Yes.
Does it work with ECR?
Yes. Works. ECR, Azure, AWS, Google Cloud. Yes, yes. So we use the AWS and Azure SDK inside Flux, so we refresh the keys and so on, so you don't lose your credentials. And it uses memcache here just to store these images metadata, like the container name and all the tags that are in the registry. So we don't store here like real images. It's this memcache is very light. You can kill it, and Flux will just refresh it. Okay, another feature that we shipped recently, it's namespace delegation. So you can create a Helm release. So this file gets created in the admin namespace. But you want to install MongoDB in the dev namespace, right? So in the specification next to the release name, you can specify a target namespace. If you don't specify it, then it's the same namespace as the Helm release. Why is this useful? Maybe you don't want to allow your dev teams to install Helm releases. Maybe you want to control the Helm release process only from an admin perspective. So if you put the Helm release file inside, let's say, the dev namespace, then someone could get to this Helm release file and modify it, right? Or delete it or whatever. Also, if you use something like this, like multi-tenancy, then you can delegate things from the cluster level to the namespace level. How we do multi-tenancy with Flux and Helm operator is like this. We have a cluster Git repo that's controlled by the cluster admins, and what's there in the cluster Git repo is the definitions of global cluster resources. Stuff like namespaces, stuff like cluster role bindings, custom resource definitions, right? And then we can say, from the cluster Git repository, we can provision a Flux instance and a Helm operator instance per namespace, and we can connect this instance to the team Git repository. So each of your dev team can have its own Git repo. You don't have to, if you don't want to merge everything under a single Git repo and all your teams have to share this one, you can still use GitOps and have a dedicated Git per team with this kind of setup. And I've made inside the Flux CD organization on GitHub, there is a special repository where I showcase how you can bootstrap all these things up with customize, and give it a try. It's very easy. It's not complicated. What this means is the cluster admin could use the namespace delegation to install Helm charts in the team1 namespace without putting those Helm charts, those Helm release definitions inside team1 Git repo. That's why we did it. So how a pipeline looks, it's very easy. You keep in your Git repo a namespace, because Helm v3 will not create a namespace for you anymore. So this was a requirement before, even with Helm v2, because we want to have all objects in Git. So you'll put a namespace there. You'll not just use Helm install minus namespace. Like Helm operator is not able to create namespaces. It will not do Helm install minus namespace. It expects for the namespace to be there pre-provisioned. And how we do that, Flux, when it detects your Git repo, it will order all the objects inside your Git repo in a certain order. For example, it will create a namespace before, or let's say, a custom resource definition before a custom resource. So a namespace before a deployment and so on. So it does apply in a certain order, so all these things can work together. Do I have time? No. Okay, so I don't have more time. So tomorrow we'll run a workshop, a tutorial, and we'll showcase all this pipeline model. If you can come tomorrow, we'll see firsthand how we can build GitOps pipelines with Flux, Helm operator, and tomorrow we'll also use Flagger and Linkerd to do the Helm release while measuring things like error rates, latency, and so on. If something fails, we'll roll back the Helm release based on other stuff than just health checks and liveness checks. So please give it a try. These are the repositories under Flux CD. We also have published on the Weaveworks website a GitOps ebook that has a nice example with a lot of microservices how you can build GitOps pipelines. And here is our pull request that we've worked last night and today at it. It's ready. We have here the install command from the v3 support. So you install the custom resource, you deploy Helm operator with Helm v3, and if you set this environment variable, Helm operator will only transform Helm releases into v3 Helm releases. If you don't set this environment variable, then you have to specify what Helm version you want inside the custom resource definition. So Helm operator is able right now to manage both tiller deployments and non-tiller deployments with Helm v3. And in our roadmap, hopefully soon we'll have a way for you to upgrade. So when you change in your Git repo from v2 to v3, we'll try to upgrade the Helm chart in place, so you don't have to, have downtime or something like that when you want to switch from one version to another. So I think it was it. Yes.
You want to tell us we're gonna have a Helm 2 versus Helm 3 situation, just like Python had?
No. No. If you use Helm operator, it will make it smooth for you. You don't have to care about it. Hopefully. Okay, thank you very much.